Hello. If you're seeing this video, that means myself or Ms. Gilmer is absent today. So we're going to teach you the notes through a video because we're not there to teach them to you normally. So pay close attention. And if you look at the sheet you're given, we'll go over and fill in the blanks as we go through the notes. So follow along and get those blanks filled in. So as you can guess, today we're talking about the types of the chemical reactions. So I'm going to start by telling you the 4 different types that you will find. So the 4 types of chemical reactions, this is your first 4 blanks, are synthesis reactions, decomposition reactions, replacement reactions, and combustion reactions. That should be your first 4 blanks. Now we are going to give the definition of each reaction individually, and then we will come back and fill in the formula and the picture and diagram. So let me slide this over really quick. Okay. So the first kind of reaction we have is a synthesis reaction. And this is when 2 or more simple compounds combine to make a more complex substance. So with synthesis, you are combining things to go from very simple to more complex. On your paper, you'll see A plus B equals ABX. Have it right here. That means you're going from A to B to AB. You're combining them together. Next kind of reaction is a decomposition reaction. These occur when a molecule breaks down into simple products. So a decomposition is the exact opposite of a synthesis. With synthesis, you go from A plus B equals AB. You combine them into something more complex. Whereas with a decomposition, you go from complex to very simple, like AB equals A plus B. So you break it down, you break it apart. The last kind, they don't have to write anything, which is good. So this is a replacement reaction. This is when one element, let me back up so you can see. This one element is going to replace another element in a compound, or if 2 elements change places. So they're going to replace each other, or they might swap places. So you either change or you swap places, okay? And our last one, I'm going to have to slide the map book over again. Last kind is a combustion reaction. A combustion reaction is kind of special. It's when oxygen, or O, combines with another compound to produce water, H2O, and carbon dioxide gas, or CO2. And then heat is given off as energy. So anytime you've lit a fire, what you've done is you added heat, and oxygen is combined and put off water and CO2 as a result. That's why you see all that heat. So that's a combustion reaction. So I'm going to pause it for a second, and we're going to come back and we're going to fill in the formulas and the backside of the notes. All right, so now we're going to go over the example formulas for the different kinds of reactions. Let's start with synthesis. So for synthesis, a good example formula is iron plus sulfur turns into iron sulfide. That is a synthesis reaction. You can combine iron fillings and powdered sulfur in a test tube, heat it up over a flame, and you will get a lot of smoke, a lot of really disgusting smells, and some bubbles. Once it's done reacting, you can shove the test tube in a beaker of cold water, it'll break, and you'll get these solid iron nuggets of iron sulfide. When I say it smells awful, I mean it. It smells awful. Let's go, and your picture and diagram is hydrogen and oxygen coming together to make simple water. You can take 4 hydrogen atoms and 2 oxygen atoms, combine them to make water. Notice that the atoms are the same on both sides. There's nothing wasted. There's no creation or destroying of matter. So decomposition next. Your example formula is water breaking down into this hydrogen and oxygen. You can introduce an electric field to water, and it will break down into hydrogen and oxygen. If you're not careful, you can get shocked because it carries a charge. Those things carry charges with them. So be careful with that. Your picture and diagram is hydrochloric acid actually decaying into hydrogen and chloride atoms. Once again, don't get your hands on that. I've had it in my mouth before by accident from working in a lab. It's not fun. All right, next is combustion. So combustion's formula, or example formula, is methane, which is a fuel, burning with oxygen and creating water and carbon dioxide gas as byproducts. So you need to watch out for that. Notice that use the oxygen as a fuel source and it puts off water and carbon dioxide as a product. Slide over to finish up with the double and single replacements. Here we go. Sorry about that. All right, single replacements first. On your paper, you'll see A plus BC. It yields AC plus B. Notice that A and B swap places. A is now with C and B is by itself. In that case, we only exchange one reactant. So please write one reactant exchanged next to that formula, okay? Next is double replacement. This is where A and B come together. It's have AB plus CD, and notice that then it's AD and CB. D and B swap places. So two people swap. So make sure you write two reactants exchanged underneath that one. Real quick, let's do single replacements example formula and double replacement example formula. First formula is single replacement. It's water breaking, well, it's magnesium and water. You combine them, you end up getting magnesium hydroxide. Notice that the water swapped on the magnesium, and now the H's are by themselves. So now you have H's, these two of the H's from water off by themselves, and they combine with magnesium. Your double replacement is pretty similar. I think this is potassium nitrate, if I'm correct. Double check me. Potassium nitrate, and this is potassium iodide. So what happens is they swap, and you end up getting iron iodide, and you end up getting potassium nitrate. So the NO3 swapped over to K, and the I swapped over to PB or lead. That's actually lead, my bad. So two people swap places. So write that formula down, get it on your notes, and we're going to roll on to the back.